You can find me as pretty much first vamp anywhere on the net. It's my Twitter and GitHub. I work for Canonical in online services, working with the back-end web services. And I love open source, of course. Why would you be at PyCon and not love open source? Let's go on to Tornado. Oh, it died. There we go. Just have to lean a little bit. Okay, let's get on to Tornado. So, it was created originally at FriendFeed. It was open source in 2009 when Facebook bought FriendFeed. FriendFeed created it primarily because they didn't like Twisted. I can kind of sympathize, to be honest. But they needed a way of doing constant real-time streams of updates to users in the browser. WebSockets weren't really a thing at the time. Oh, they were, but they weren't very well developed. But there was long polling, constantly updating a stream to the browser. So they came up with Tornado as a web server solution written in Python. Pure Python. That's an important thing because it means that it's easy to get it going under PyPy, Python 3. It's fully Python 3 compatible. It does have some speeds up with C modules, but for the most part you can pretty much run it anywhere you can run pure Python. It does have WebSocket support now, obviously. And one of the first things to say is that it's actually not a framework, but pretty much everything I'm going to discuss later on makes it look like a framework. This is pretty much my Simpsons nerd moment. So, I think you'll find that's not a framework. That's a web server. No, okay. I mention this because it doesn't necessarily always have all of the framework components that you want, like an ORM or a really, really fully mapped out routing system, and a few other things that you get out of the box with things like Django or even Flask, or add-ons for Flask. But it does have some of the features like sessions or template system, although because everything is loosely coupled, you can swap out pretty much anything you like. For example, a lot of people usually use Ginger 2 rather than the templating system in Tornado. So the Tornado templating system is fine. It's quite fast and very similar to Ginger and Django templates. And it has support for callbacks via coroutines and futures. Actually, in the latest version of Tornado, everything is done by a coroutine, which I'll slightly cover. It isn't really the talk to cover what a coroutine is, and pretty much everyone I talk to who supposedly should know what a coroutine is usually can't describe one anywhere, other than it's kind of like a generator, but not. So the usual disclaimer of what asynchronous means in this case, it doesn't mean parallel. It means, well, in this case, cooperative and non-blocking. So whenever you do some sort of I/O that might normally block your thread, if you're used to doing threaded programming or anything with lightweight threads like in Greenlit or in Twisted with the deferred stuff, then you unblock your current process and go and do something else, and then switch back to what you were doing later. It has non-blocking I/O support in both the HTTP and client and server side, which is important because you probably want to do some form of HTTP request inside your web service these days, calling out to a third party, for example, and you don't want that to be blocking either. And there are several ways of doing these asynchronous tasks via callbacks and futures and the coroutines themselves. That's less important, but mentioned just for completeness. For example, here's Motor, which is the standard way of using MongoDB in Tornado. So here you can see that we're using what looks like a generator. It's a coroutine. It is a generator and a coroutine, I suppose, to perform an operation on MongoDB and get the result back at some point when that result is yielded. So going back from the internals of how this stuff is done, let's look at more of a why. So it's great for RESTful web services, which is what you often find smaller frameworks like Flask or Cherry are nicely suited for. Something small, a small microservice that does one nice thing in a specific way. Oh, that's not too bad up there. So if you've done any sort of web framework work with Django or Flask or any of the others, and you probably recognise this general sort of setting up a route and setting it up for a handler. But if you haven't, I'll just quickly walk through it. At the top, obviously, we have imports to import a few. There's something specific to Tornado and something specific to this application, which is the resource handler, which is in a module in this application. And here we just define the application itself. Usually there's only one application unless you're doing testing, which is whatever is running on specific ports or multiple ports when it comes to WebSockets and listening for incoming connections. And we just set up a tuple of, in this case, the resources path, which can be a regular expression, like in most routing handlers. And it just says, this is the handler that will handle anything that goes to this path. In the handler itself, which yet again looks like a lot of common web framework classes, request handlers, we inherit the Tornado request handler, and then we just have some setup. This is the prepare method, which allows you to do a few things at the start of every request. So you might set up your database client connection, which may of course come from a pull inside the application itself, but you want a nice easy handler to it. You want to go self.db or something else, so we'll define that here in the prepare method. Or in this case, well, we always want the user ID argument from the request. And the important thing about doing anything asynchronous in Tornado is we have these nice decorators for asynchronous and a few other things as well. If you don't define it as an asynchronous method, the get method here, which is obviously a HTTP get, then when the method finishes, that will be the end of the request. It will not be a continuous request. Nothing will happen after it. You can use it as a long polling request to keep sending data back to the user, or do anything like that. If you don't define it as asynchronous, it will just finish, and a response will be sent back to the user, and you'll probably end up with an exception being logged in your application because you tried to do something later with a request that was no longer open. So here we define it as asynchronous, and we do something with an add timeout. Another note is this I/O loop, which is how Tornado works, very similar to a lot of other asynchronous frameworks like Twisted or even in Gevent or Eventlet, where you have an I/O loop which basically is a continuous loop which goes round and round and looks for events like an incoming client request or even a callback that has been added to it or something of that nature. So on the I/O loop, we say add this timeout, which is basically a timed callback. It says time plus 60, call self.end, so this finishes. It was asynchronous, so it didn't finish the request. The user's request will be open, will be sat waiting. If you're doing curl will just be sat there for 60 seconds or maybe longer, depending on other factors. And then underscore end will finally fire. We'll do self.finish. Self.finish is a shortcut for doing a write and a finish of the request. You can also do self.end, which is why I called that underscore end, to finish the request and do no writes. Or you can do self.write, blah blah blah, self.write, blah blah blah, self.end. This is just a quick way of doing those in one go. And that we have in theory a long polling application. It takes longer. We could keep writing data out to the client and flushing it through, and they could keep getting data back. As it is, we just say hello world and finish. The other nice thing about Tornado is the fact that it is loosely coupled, and you can mix it with other tooling and libraries. There are several projects which will use Tornado for long polling, WebSocket, Socket.io, etc. handling, and we'll use a Django application to do more complex pieces of the application. So your Tornado application literally does feedback to the user over long requests and just runs on a separate port and is routed with a load balancer at the front end to the right place. And then the Django application will do lots of lots of nice views to do CRUD stuff for updating objects and allowing you to set profiles and other things like that. So that is one use case. You can build your entire application in Tornado, and I've built an entire application in Tornado, but the fact that you can mix and match and use Tornado for what it's particularly good at is a bonus. And as I mentioned here, it's usually good if there is already a library for a back-end component for Tornado that is asynchronous. For example, I mentioned the Moto library for MongoDB back there. There is an inbuilt MySQL client in Facebook, purely because back before, not in Facebook, getting ahead of myself, in Tornado, back before Facebook bought FriendFeed used MySQL for everything, so they had it, the client inbuilt. There are since lots of other clients. There's an asynchronous AMQP client, a Redis one, a ZeroMQ one. They sometimes always aren't as fully featured as their non-blocking counterparts, and some are in fact just wrappers around the non-blocking versions, which use the Greenlit library to unblock when they need to and defer to a coroutine in Tornado instead. The Moto client does just that. It actually just wraps the PyMongo library inside, which has a great advantage because it means that it can always update the version by just acting as a wrapper to the internal calls. I mentioned Socket.io here. I've used Socket.io with Tornado previously, but I actually usually found that the gevent_socket.io library usually has much better support for doing Socket.io with Python. I don't think there is a sock.js Tornado handler. There is. Excellent. Thank you. So there's a sock.js one as well. I don't know about its support either, but it's probably good because sock.js is actually quite a lot lightweight compared to Socket.io, so there's less to support and keep track of the API changing. Well, with regards to Socket.io, I found the gevent version to be better, but you might not want to use gevent for various reasons. It does have a lot of, as previously mentioned, a lot of batteries included into Tornado. The template thing, as I mentioned before, but also auth handlers, including, because FriendFeed, obviously what they did was social media, and signing in through Twitter is something they wanted to do, already includes a Twitter OAuth client specifically for OAuthing with Twitter. And there are a few others like Facebook, funnily enough, because Facebook bought them and open sourced them. And a few others. You can easily write your own auth handler, which is quite nice. The HTTP client and server, but also the TCP client and server, which is great because one of my other use cases was to write a non-blocking TCP client inside a Tornado handler, which was acting as a monitor for a remote system over a specific port. In Tornado 4, which is just released this year, there is an even better TCP client module which sets up lots of defaults such as non-blocking DNS requests and non-blocking SSL and IPv6 support, and it has quite a nice simple API to call. If you need to use actual threading, there is thread pool built in, which you can call, and also you can switch out the library for using the thread pools. The async DNS queries also support different backends. The default is the Sierra's library if it's available, but that's not always built and available. Or you can do it through threads or the twisted resolver. And process pooling with bound master socket port, which I will explain. The idea there is that you can have multiple twisted processes to take advantage of your CPU calls, or maybe even physical CPUs, and then bind those on a front process to a single socket. So you have a front socket to port 80, and it will then bind to or rather it will be a map to those extra processes on the back end. So you don't need to care about doing routing to different ports on your box to those different processes to take advantage. Tornado.platform.twisted is excellent. It provides a wrapper around twisted libraries. For example, the excellent protocol support in Twisted. You can pretty much use any kind of TCP or UDP protocol from Twisted, because those guys have implemented pretty much all of them, or a third party will have done. And you can pretty much just call those in the same way that you would from a Tornado request handler using the wrapper inside platform.twisted. And as of Tornado 4, you can actually use the twisted IO loop instead of the Tornado IO loop, as long as you're also using twisted 14 and above. Which means if you want to mix and match your twisted code, it becomes even a lot easier, because you don't have to worry about different I/O loops clobbering each other, or worry about using different processes. So the WebSockets are long polling and support via third-party clients for various front-end socket wrappers, and also an SMTP client for one of those times when you definitely must send an email from inside your web service. Bonuses. So in Tornado 4, yet again, everything is pretty much a coroutine, and nearly everything will also retain a future. Skipping onto the second but last line there of support for futures. Of course, futures is now no longer just PEP 3156. It is in 3.4 and also backported in the Tulip library. So if futures are available, Tornado will actually use concurrent .future as opposed to its own. Well, it will wrap those futures. So calling a future instance inside Tornado is pretty much the same thing as using actual futures in Python. And you can use you can return a future from your own handler as opposed to doing a callback. So if you just want to say return this future, this thing that will happen at some point, that will also work the same as if you said add callback or the twisted parallel is defer. Going back up the stack, you can wrap coroutines with greenlets quite easily. As I said, the motor client does it and a few other ones do it, which means you get the advantage of using the Tornado API without having to worry about re-implementing an entire library, and using greenlets under the hood to wrap that blocking process. Because a lot of people don't like using things like eventlet or G-event, as Glyph himself quite recently had a large rant about his dislike of the library and problems with using greenlets for asynchronous stuff. But using these methods, you can just use a quite nice ordered API for it instead. PyCal and libcal, there is inbuilt support in Tornado for using both of those, obviously libcal via PyCal, in which if you set the right setting for the HTTP client, it will actually use PyCal for all of its underlying HTTP requests. And anything which libcal supports it can then do, but it's extremely fast. It has a very good underlying socket layer, which will fire off requests incredibly quickly, and waiting for the blocked calls of those inside Tornado is very fast. I mentioned before that it runs on PyPy, but I wrote these slides originally when something running on PyPy was more unusual. I'm going to give a quick plug, because the last time I gave this presentation was at a conference when I was actually announcing this module. So it's been out for about a year now, but T-Requests is a library I wrote in order to get around a specific problem I had at a previous job of using a library inside Tornado, which itself used Kenneth Reese's excellent Python request library, which itself is not blocking, non-blocking. It is completely blocking, because that's up for you to sort out. So I wrote this client handler for Tornado, so you could swap out the default async HTTP client for this one. It does use Greenlet to wrap the Python request calls. So that's one caveat. I don't find that much of a caveat. Greenlet pretty much works in most places. As an example, say I have this, imagine there's lots of code here, and it does lots of complex things, but its underlying point is that it eventually calls request.post to some external service and returns some JSON. So that's going to block inside my Tornado thread. I don't want it to. So I import my setup session from T-Request, which is pretty much all you need. Call it, with it. It does have the ability to override various options, but I'm just going to use the default. The default basically says every time request is used, I'm going to use this. Wrap this uses the Tornado library, which is a wrapper for Tornado coroutines with Greenlit, which I'm a co-author of. So you Raka get in Tornado saying when I block with something which uses Tornado, so the underlying handler has to use Tornado, which is handled by T requests. And I call, as usual, as normal, not even actually caring that it's an async call. Response equals Bob's big data. First. And as we know from the previous slide, that's actually doing a request first, and instead that will get wrapped inside a Greenlit, and when it's and defer back to the coroutine that is actually running the Tornado process, and I can carry on with doing any other async request. So I could have I could have like 50 HTTP gets to this web handler, and they will all pretty much start firing off requests inside Big Bob requests rather than blocking on the first one. And then I just get this will unblock and come back, and I will have the response here. I originally thought that I would add a Tornado style API around this to follow the path of adding a callback or a future and then getting the response back. But unfortunately, then you're doing something in a different way to the docs of the library you're using. You know, you use the paper trail library or the new relic library, and it has a bunch of examples for doing a request to their API. That means to use inside your application, you're going to need to map that over to a Tornado way of doing that, as opposed to just using the examples. Doing it this way, it all just works. You just need to remember that one specific piece of code is actually doing something asynchronous, which is a lot easier than having to wrap everything and go the long way around. It's available on my GitHub account, /t-requests. It's open source. Feel free to use it. It has tests, which is unusual. My slides are all available on that GitHub account. I actually keep meaning to open source it. I probably will do later, but I think I've got some images in there that are copyrighted, so I might change that first. My slide illustrations were done by my good friend Jonathan Oliver. If you need anyone to do any sort of illustrations with quite a nice little twist, please look him up. And I'm here till tomorrow. If you want to grab me and say hi. Thank you. Any questions? Excellent, thank you.